Hello, welcome friends. I am RM Gurud, working as assistant professor in civil engineering department in Cherry Institute of Technology, College of Engineering. This is module number 2, compass surveying. Today we are going to see some of the problem in the compass survey. So in this slide we are going to see the magnetic declination. It is nothing but the horizontal angle between the magnetic meridian and true meridian. When the north end of the magnetic needle is pointed towards the west side of the true meridian, the position is termed as declination west, that is theta west. Similarly, when the north end of the needle is pointed towards east side of the true meridian, the position is termed as declination east, that is theta e. This figure indicates the magnetic declination. The theta is the horizontal angle between true meridian and magnetic meridian. And in case number 1, declination is east, that is magnetic meridian is shown towards right, that is towards east, whereas in case of second figure, magnetic north is shown towards left, that is towards west. And theta is the horizontal angle between magnetic meridian and true meridian. Then we will see how to determine the true bearing and magnetic bearing when the declination is given. The formula is the true bearing equal to magnetic bearing plus or minus declination. Use plus sign when the declination is towards east. Use negative sign when declination is towards west. Similarly, magnetic bearing is calculated as true bearing plus or minus declination. So use positive sign when declination is towards west and use negative sign when declination is towards east, because the declination is towards west. In this slide you will find the determination of true bearing and magnetic bearing. True bearing of AB equal to magnetic bearing minus declination, and magnetic bearing of AB equal to true bearing minus declination. In this slide we are going to see the problem how to calculate the declination when the true bearing and magnetic bearing of line is given. So in the given problem, true bearing of line AB is 357 degree and the magnetic bearing of line is 1 degree 30 minutes. So we are supposed to calculate the declination. Also we have to find the true bearing of AC, which has magnetic bearing equal to 150 degree 30 minutes. This magnetic declination is the horizontal angle between true meridian or true north and magnetic north. So 1 degree 30 minutes is the true value of true bearing, whereas 360 minus 357 degree is the horizontal angle between, it is the horizontal bearing. This slide refers to how to detect the local attraction. The presence of local attraction at any station may be detected by observing the fore and back bearing of line. If the difference between fore and back bearing is 180 degree, both end stations are free from local attraction. If not, the discrepancy may be due to an error in the observation of either fore and back bearing or both. Presence of local attraction at either station or presence of local attraction at both the stations. So in this slide we are going to see method how to eliminate the local attraction by included angles. The following steps are followed. First, computing the included angle at each station from the observed bearing in case of closed towers. Starting from the unaffected line, run down the correct bearing of successive sides. And then we will see the problem on computation of angles. The following bearings were taken for a closed towers. We are supposed to compute the interior angles and correct them for observation error. Assume the bearing of line CD to be correct. Adjust the bearing of remaining sides. So by considering the fore bearing and back bearing of line CD, we found that there is exact difference between 180 degree. So therefore, whatever the bearings which are taken from C or D, they are correct. In this slide we are going to see the problem how to calculate the declination when the true bearing and magnetic bearing of line is given. So in the given problem, true bearing of line AB is 357 degree and the magnetic bearing of line is 1 degree 30 minutes. So we are supposed to calculate the declination. Also we have to find the true bearing of AC, which has magnetic bearing equal to 150 degree 30 minutes. Then we'll compute the angle D as back bearing of CD minus forward bearing of D. Again, angle D is less than 180 degree, therefore it is include angle. Similarly, angle E equal to back bearing of D minus forward bearing of EA. So it is 99 degree 10 minutes. So whenever we are going to make the summation of all included angles, the sum of all included angle is 539 degree 35 seconds. So theoretical sum is 2n minus 4 into 90 degree, that is 540 degree. Therefore error is minus 25 minute. So in this slide we are going to see how to distribute the error. Since the error is negative, we have to apply the correction positive. So we have to add the calculated angles by 5 minutes. So therefore angle A equal to 50 degree 10 minute, angle B equal to 138 degree 45 minute, angle C equal to 131 degree 5 minute, angle D equal to 120 degree 45 minutes, and angle E equal to 99 degree 15 minutes. So in this slide we are going to see how to compute the angles. Starting with corrected bearing of CD, all other bearings can be calculated as under. Forward bearing of D equal to bearing of DC minus angle D. So 350 degree 15 minute minus 120 degree 45 minute equal to 230 degree 5 minutes. Since the back bearing of forward bearing of D is 230 degree, therefore back bearing of D equal to 230 degree 5 minute minus 180 degree. So the back bearing is 50 degree 5 minutes. Again, forward bearing of EA equal to back bearing of DE minus angle E. So 50 degree 5 minute minus 99 degree 15 minutes plus 360 degree. So it is 310 degree 15 minutes. So therefore back bearing of EA equal to 310 degree 15 minutes minus 180 degree, that is 130 degree 15 minutes. Forward bearing of AB equal to back bearing of EA minus angle A, 130 degree 15 minutes minus 50 degree 10 minutes. So whatever the angle we receive, it is less than 180 degree, therefore the forward bearing of AB equal to 80 degree 40 minutes. Then back bearing of AB equal to 80 degree 40 minutes plus 180 degree, so it is 260 degree 40 minutes. Similarly, forward bearing of BC equal to back bearing of AB minus angle B, that is 260 degree 40 minutes minus 130 degree 45 minutes. So the angle is 121 degree 55 minutes. Slide we are going to see how to compute the angles. So back bearing of BC equal to 121 degree 55 minutes plus 180 degree, it is 301 degree 55 minutes. Similarly, forward bearing of CD equal to back bearing of BC minus angle C, so 301 minus 131, so it is 170 degree 15 minutes. Similarly, back bearing of CD equal to 170 degree 15 minutes plus 180 degree, and it is 350 degree 50 minutes. Since this particular bearing matches with readings taken from D, therefore we received the check. This slide refers to the closed towers in which observed bearings are recorded as forward bearing and back bearing, and we are supposed to calculate the corrected bearings because the stations are suspected by local attraction. So first of all, from the forward bearing of each line, first of all we will try to draw the sketch of closed towers. This is towers ABCDEA, which is anti-clockwise in direction, which is shown by making use of forward bearing of line. So this slide refers to the observed bearing in the form of forward bearing and back bearing and their differences. So if you consider the line AB, the difference is 170 degree. If you consider BC line, it is 183 degree. If you consider the line CD, it is 170 degree. If you consider DE, it is exactly 180 degree. And when you consider the line EA, the difference between forward bearing and back bearing is 182 degree 30 minutes. So in order to calculate the interior angles, we are supposed to Calculate the forward bearing of AB minus back bearing of EA as angle A. So 191 degree 45 minutes minus 147 degree 45 minutes, it is 44 degree. Similarly, interior angle B equal to forward bearing of BC minus back bearing of AB, it is 26 degree 30 minutes. Similarly, exterior angle C equal to back bearing of BC minus forward bearing of AB. Since the difference is greater than 180 degree, it is treated as exterior angle. So the interior angle C equal to 360 minus 200 degree 50 minutes as an exterior angle. So the interior angle C equal to 159 degree 45 minutes. Similarly, interior angle D equal to forward bearing of D minus back bearing of CD. So it is 42 degree 15 minutes. Similarly, interior angle E equal to forward bearing of EA minus back bearing of DE. 330 degree 15 minutes minus 62 degree 45 minutes. Therefore, it is 267 degree 30 minutes. So sum of interior angle equal to 540 degree, which is equal to 2n minus 4 into 90 degree. Therefore, there is no error of local attraction. This figure indicates the magnetic declination. The theta is the horizontal angle between true meridian and magnetic meridian, and in case number 1, declination is east, that is magnetic meridian is shown towards right, that is towards east, whereas in case of second figure, magnetic north is shown towards left, that is towards west. And theta is the horizontal angle between magnetic meridian and true meridian. Then we will see how to determine the true bearing and magnetic bearing when the declination is given. The formula is the true bearing equal to magnetic bearing plus or minus declination. Use plus sign when the declination is towards east. Use negative sign when declination is towards west. Similarly, magnetic bearing is calculated as true bearing plus or minus declination. So use positive sign when declination is towards west, and use negative sign when declination is towards east. The values of corrected bearings are tabulated in this particular table, showing the difference of exactly 180 degree for all the lines. It refers to the references used. So friends, thank you.